Welcome to Python Linear Regression. Today we will learn how to predict values using simple and multiple linear regression in Python. We will start with basics, explore real data, and build our own prediction models. No experience needed. Let us begin. Running the cell now. Getting set up is important. Let us hide warnings so we can focus. We are preparing a clean workspace. This brings in Python's warnings library. This tells Python to hide any warning messages. Now we show we are ready to go. Running the cell now. Type print, all set, and run it for practice. What is linear regression? Linear regression is a way to find a straight line relationship between numbers. It is used to predict something using one or more clues, like guessing house prices from size and location. It is one of the easiest, most important tools in data science. Running the cell now. Let us warm up by using a linear formula. Let us start with a comment. Comments explain the code and are ignored when the code runs. We are storing the number 10 in a variable named x. Now we use a simple math formula, just like y equals 3x plus 7. This prints out what x and y are. Running the cell now. Change x to 20 and run again. What do you notice? Loading real data, California housing. Let us use real-world data to make our learning interesting. We will use the California housing dataset. It has data like home prices, number of rooms, and population, perfect for regression. Running the cell now. Now we load the California housing data and take a peek. This comment reminds us what we are doing. We use scikit-learn to get the dataset. Scikit-learn is a library for machine learning. Pandas helps us work with tables like spreadsheets. We ask for the data in a table format. We copy the data to df so it is easier to work with. Let us see the shape, which is rows and columns. Let us preview the first 5 rows. Running the cell now. Try using df.tail to see the last 5 rows. It is good to check what features and labels we have. We add a comment for clarity. This shows the column names in our data. Running the cell now. Can you guess what medhouseval means? Now let us learn more about our dataset by summarizing the numbers. We add a reminder for what the next line does. This gives the mean, standard deviation, and more, for each column. Running the cell now. Practice, try describing just one column like df, medinc.describe. Let us check the target variable. This is what we want to predict. This reminds us of our purpose. This line shows the first few values for home price. Running the cell now. What is the minimum and maximum home price? Try df, medhouseval, .minute, and max. What makes a good input, feature? Features are clues we use to make a prediction. We want features that matter, like income or number of rooms. Choosing good features helps make better predictions. Running the cell now. Let us train a simple model that predicts house value from income only. The comment shows we are doing a simple regression with one feature. This splits the data into training and testing parts. This tool can create and use linear models for us. We pick a column, median income, to try. We set our features to one column and our target to home value. We do not want our model to see the answer in advance. We split so 80% goes to training, 20% for testing. We use random_state for the same results each time. We create the model. We train the model with the training data. Now our model is ready. Running the cell now. Try using a different feature, like Mave rooms, for practice. Let us see what the model predicts for new data it has not seen before. We are making predictions using our trained model. We ask the model to predict home values using our test inputs. We print the first 5 predictions so we can see them clearly. Now we check what the real answers were for those rows. Running the cell now. How close are the predictions to the real values? It is important to measure how well our model predicts. A comment for our goal. We use a tool to check prediction accuracy. We calculate the average squared difference between predictions and real values. We print it out to see. Lower is better. Running the cell now. Try printing MSE *** 0.5 to get the root error, which is easier to understand. Let us see a picture of our predictions compared to real values. We add a comment for clarity. Matplotlib lets us draw plots and charts. We show real data points as blue dots. We draw the predicted line in red. We label the x-axis with the feature name. We label the y-axis with the target name. We add a simple title. We display the blue and red labels as a legend. Finally, we show the plot window. Running the cell now. If the red line is close to the blue dots, our model is doing well. Multiple linear regression. Now let us use more than one feature for better predictions. This lets us capture more patterns in the data. It is like using extra clues to guess the answer. Running the cell now. Now we use 3 features to help the model make stronger predictions. We begin with a helpful comment. We list the feature names we want to use. We select these columns for our new input data. We split into training and testing sets, just like before. We create a new linear regression model. Now we train this model with more data. We use the model to make predictions for the test data. Let us print out the first 5 results to check. Running the cell now. Add or remove features and see what happens. We should check if using more features gave us better predictions. A comment about our next step. We calculate mean squared error for our multiple feature model. We print the mean squared error value. We take the square root to make the scale more readable. Running the cell now. Compare numbers with single feature regression to see progress. Let us check which clues matter most to the model. This comment reminds us what we are looking at. We create a dictionary matching feature names to their weights. We show a helpful label for our print. We loop over each pair of feature and confidence. We print each feature and its weight. Running the cell now. Higher weights mean greater influence on the prediction. Let us try the model with new values that we choose. We add a clear comment. Here are our made-up values for median income, average rooms, and average occupancy. We make a prediction on this new input. Here is the predicted home value. Running the cell now. Practice, change the numbers and run again to see how the result changes. Let us make the computer ask us for our own numbers. We label our purpose here. We ask the user to type median income, then convert it to a number. We request the average number of rooms and convert to number. Now we ask for average occupancy and convert to number. The model uses all 3 of our answers at once. Our prediction is shown based on what we entered. Running the cell now. Try different combinations and imagine what each change means. Common problems and best practices. Regression works best when relationships are fairly straight. Too many features can confuse the model or cause overfitting. Splitting data with random _state lets everyone repeat your work. Always check results to be sure predictions make sense. Running the cell now. Let us see what happens if our input is broken. The comment tells us we are testing for errors. We try to predict, but we will use a value that does not make sense. Here we pass none, which means nothing. The model will not like this. We try to print what happens if it works, but it should not. If there is any error, we catch it and explain. The program prints a helpful message and the error reason. Running the cell now. Try using a string instead of a number and see what happens. Challenge: try it yourself. 1. Train a simple regression using Aave rooms as your only feature. 2. Predict home values and plot predictions versus real values. 3. Measure the mean squared error. See if you can improve. Share your results below the video. Running the cell now. Recap. Today you learned the basics of simple and multiple linear regression. We explored real housing data, built our own models, made predictions, and found out how to improve them. Practice makes perfect. Try again with different features. Running the cell now. Thank you, and next steps. Subscribe to the channel for more Python and data science tutorials. Comment with what you tried and what you want to see next. Practice, experiment, and you will be a data scientist in no time. Running the cell now. Try making predictions with other datasets. Thank you for learning with us.